All right. Okay, so we are back for this last video. And so I asked you guys to actually try these two problems on your own. So let's go ahead and look at this one. This one actually had some different parts that we had to do. So what I've done so far is I've actually made my normal curve with my mean and then my standard deviations away. But this one, if we read the problem, it did not give me my standard deviation, nor did it give me my mean. The piece of information it did give me was that 68% of the rents were between 1145 and 1375. So that was the first thing it is. I actually went and put those with one standard deviation away. I knew that these first bins, these first markers represented that one standard deviation. I knew smack dab in the middle of those had to be the mean. So I took these two numbers and I averaged them, and that's how I got my mean. And then I knew once I had the mean that the distance from here to here or the distance from here to here had to be a standard deviation. So I subtracted the mean and one of those numbers to get my standard deviation. Now let's actually go ahead and answer the question. So it says find the probability of finding a studio apartment for less than 915 a month. So the first thing I'm going to do is I'm going to go and find that 915. Well, that's way down here. I know that the only number on the other side of this is going to be 0.15%. So if you were looking for a studio apartment in San Francisco when this data was taken, which I'll be honest was quite a while ago now, you had a less than 1% chance of finding a place for a rent that was $9.15 or less a month. All right, let's go ahead and look at the next question. Find the probability of finding a studio apartment for more than 1490. So this time we're looking for things that are larger than 1490. I'm going to find that 1490, it's right here. We're going this way. So that first chunk is going to be 2.35% plus 0.15%, and that gives us a total of 2.5%. So higher chances of finding one that is larger than 1490 than chances of finding one that's less than 915. All right, and I think this one had one last question. So find the probability of finding one that's between these two rents. So between 1030 and 1375. So once again, I'm going to go find 1030. I'm going to find 1375. Well, here, once again, I know that this chunk is 68. I'm going to add this chunk, which is 13.5, and that gives me an 81.5% chance. So if this was my budget that I was going around looking for, I have a really high likelihood to find a studio apartment in my budget range. So this is the one with the apartments. The last one here was talking about the heights of 12-year-old males. And this one's given to us in centimeters instead of inches. That's okay. Same thing though, start with the mean, smack dab here. The 9 standard deviation gave me my bins, and now I'm ready to answer the questions. So the first question is, what percent of these boys will be over? So this is larger. Let me put my X first. I'm going to larger than 158. So the same thing, I'm going to go and find that 158. I know I'm going here. I think we've done this chunk before, but we can also do it again. So this is going to be the 13.5. That was right here. Here's the 2.35, and then down here is the 0.15, and that gives me 16. So you should have gotten that there was a 16% chance of having a height larger than 158. And we can do this very, very, very last one, which is what percentage of 12-year-old boys will be between. So we like the between ones. It's going to be 131 to 140. So I'm going to go and find those on here. Here's my 140. Sorry, we got a bell going in the background. And there's my 131. That itself is just one little bin. And so this bin is simply 13.5%. So there is a 13.5% of boys who fall within 131 and 140. So here you have it. We've talked a lot today. We started with what is a density curve, what is a normal curve. We saw that there are other types of density curves. We talked about normal ones being symmetrical. You're always going to have that mean in the middle, and then one standard deviation away on either side, another standard deviation away, a third one. Here we looked at what that might look like with real life data. If you're just given the data to see, is it normal? You can actually find your mean, your standard deviation, and then see how much of your data, your actual data points falls within it. And so here we saw that these were close to the empirical rule. So they were close to being normal. We can say they're approximately normal. Same with the strikeouts. Then we learned what the empirical rule actually is, saw how it breaks down on the curve, and then saw how we can use that to determine what percent of data should fall in each of these categories if we are told that it is approximately normal. So if you're told it's approximately normal, you can go ahead and set out this curve and then determine what percent of data falls within these population bins that we have been looking at. And that is pretty much everything you need to know about the empirical rule and normal distributions.